The global aerospace industry believed that developing advanced commercial aircraft engines would remain a field dominated by only a handful of companies. Modern jet engines are among the most difficult technologies humans have ever created. They operate under extreme heat, enormous pressure, and incredibly demanding safety standards, while maintaining fuel efficiency and reliability for thousands of flight hours. Because of this complexity, the world's commercial aviation market became heavily dependent on major Western engine manufacturers such as General Electric, Rolls-Royce, Pratt & Whitney, and Safran. Their technologies powered most of the modern aviation world, from narrow-body passenger jets to long-haul wide-body aircraft. But now, a Russian engine program that many once underestimated is attracting growing international attention. The engine is called the Aviadvigatel PD-8, and its latest testing progress is becoming one of the most important stories in modern Russian aerospace. At first glance, the PD-8 might sound like just another regional aircraft engine under development, but in reality, the story behind it is much larger. The PD-8 represents a major strategic effort by Russia to reduce dependence on foreign aerospace technology and rebuild domestic industrial capability in one of the world's most advanced engineering sectors. And that is exactly why its testing progress matters so much. To understand why the PD-8 became such a major topic, we first need to understand how modern aviation actually works. Commercial aircraft are not isolated machines. Every airplane depends on an enormous ecosystem involving engines, avionics, software, maintenance support, spare parts, certification systems, and long-term technical partnerships. Airlines do not simply purchase an aircraft once and forget about it. They rely on decades of continuous support to keep fleets operational safely and efficiently. This interconnected system made globalization extremely effective for aerospace companies over the last several decades. Manufacturers from different countries specialized in different technologies, and international cooperation became normal across aviation programs. However, geopolitical tensions and sanctions gradually exposed a major weakness in this model. Countries relying too heavily on foreign aerospace systems realized that disruptions in supply chains could threaten entire aircraft programs. Russia experienced this challenge directly. Aircraft like the Sukhoi Superjet 100 originally relied heavily on foreign systems and international cooperation. One of the most important components was the SAM-146 engine, developed through cooperation involving Russian and French aerospace companies. Initially, this international strategy allowed the Superjet program to access modern engine technology while improving competitiveness in global markets. But over time, sanctions and geopolitical restrictions complicated access to spare parts, maintenance systems, and technical cooperation. This created operational uncertainty for airlines and raised concerns about the long-term sustainability of aircraft programs dependent on foreign suppliers. Russia's response was clear: accelerate domestic engine development. That is where the PD-8 enters the story. The PD-8 was designed as a fully domestic turbofan engine intended primarily for upgraded versions of the Sukhoi Superjet program, now increasingly referred to as the SJ-100. However, the importance of the engine goes far beyond a single aircraft. In reality, the PD-8 became part of a broader strategy to rebuild independent aerospace capability across Russia's aviation industry. Developing a commercial jet engine from scratch is extraordinarily difficult. It requires advanced metallurgy, precision manufacturing, aerodynamic optimization, thermal engineering, digital monitoring systems, and years of testing. Engines must perform reliably under extreme conditions while maintaining efficiency and safety standards across thousands of operational hours. Even small failures can create enormous safety and financial consequences. This is why only a small number of companies dominate global engine manufacturing. So when reports emerged showing the PD-8 progressing through advanced testing phases, aviation analysts began paying closer attention. The engine was no longer simply a theoretical replacement program. It was becoming an operational reality. The phrase, "finally completing test," matters because engine certification and testing are some of the longest and most demanding phases of aerospace development. Before entering commercial service, engines must undergo extensive ground testing, environmental testing, endurance testing, vibration analysis, thermal stress evaluation, and real-world flight testing. Engineers push engines through extreme operating conditions to verify reliability, efficiency, and safety. According to Russian aerospace reports and industry updates, the PD-8 has gradually advanced through these critical testing stages, including integration into test aircraft platforms. This signaled that the engine program was moving closer toward operational readiness, rather than remaining stuck in purely experimental development. One reason the Western aerospace industry watched this progress carefully is because domestic engine capability changes strategic dynamics significantly. Aircraft manufacturers that control their own engines gain much greater independence over production, maintenance, export decisions, and long-term industrial planning. Engines are often considered the heart of an aircraft program because they influence performance, operating costs, maintenance schedules, fuel efficiency, and airline economics. Without reliable engine access, even advanced aircraft programs can struggle. This is why the PD-8 became more than just an engineering project. It became a symbol of industrial resilience. Another reason the engine attracted attention is because regional aviation remains extremely important globally. Aircraft like the SJ-100 operate routes that connect smaller cities and regional hubs, where larger narrow-body aircraft may not be economically practical. Efficient regional aircraft allow countries to maintain transportation networks across large geographic territories, while supporting economic activity and domestic connectivity. For Russia specifically, domestic regional aviation has strategic importance because of the country's massive geographic size. Maintaining reliable air links between distant regions requires aircraft capable of operating efficiently under varied conditions. A domestically supported aircraft and engine ecosystem reduces vulnerability to international supply disruptions. At the same time, it is important to avoid exaggeration. The phrase, "shocking the West," often creates the impression that Russia suddenly surpassed Western aerospace technology overnight. In reality, Western engine manufacturers still possess enormous experience, operational history, certification networks, and industrial scale built over decades. Companies like General Electric and Rolls-Royce remain global leaders in advanced aerospace propulsion systems. However, what surprised many analysts was not necessarily that Russia wanted a domestic engine, but that meaningful progress continued despite sanctions, industrial pressure, and technological difficulty. Building engines is one challenge. Building them reliably, certifying them, producing them at scale, and supporting them operationally for decades is even harder. Yet the PD-8's progress suggests Russia remains committed to rebuilding long-term aerospace independence despite major obstacles. The engine also reflects a broader global trend towards strategic technological sovereignty. Around the world, countries are increasingly attempting to reduce dependence on foreign suppliers in critical sectors such as semiconductors, energy systems, defense technology, and aerospace manufacturing. Aviation is especially important because aircraft combine multiple advanced industrial capabilities into one platform. Modern aerospace competition is no longer only about who builds the best airplane. It is also about who controls the supply chain, who controls maintenance ecosystems, who controls engine technology, and who can sustain operations independently during geopolitical instability. The PD-8 fits directly into this larger transformation. For airlines, however, operational reliability remains the ultimate test. Airlines care deeply about maintenance costs, fuel efficiency, spare parts support, technical service networks, and long-term reliability. Any new engine entering the market must prove itself through years of successful real-world operation before achieving widespread confidence. Certification also remains critical. Commercial engines must meet strict aviation safety standards before operating extensively in international markets. This process requires enormous technical documentation, testing data, and regulatory validation. Production scale is another challenge entirely. Manufacturing advanced engines consistently while maintaining quality standards demands highly specialized industrial infrastructure and skilled labor. Aerospace manufacturing tolerances are extremely precise, leaving little room for error. Still, despite all these challenges, the PD-8's progress demonstrates something important about the future of global aerospace. the industry is becoming increasingly multipolar. Instead of one globally integrated aerospace system dominated entirely by a few Western suppliers, multiple countries are attempting to develop more independent aviation ecosystems. Whether these programs fully succeed or not, they are already changing strategic calculations across the industry. In many ways, the PD-8 story is not just about one engine. It is about how modern aviation is evolving in a world where industrial resilience, geopolitical pressure, and technological independence are becoming just as important as pure commercial efficiency. And perhaps that is what truly caught the world's attention. The surprise was not that Russia wanted its own advanced engine. The real surprise was seeing the program continue advancing through critical testing stages despite enormous technical and geopolitical obstacles. Because in aerospace, completing tests is not just a technical milestone, it is proof that an idea is moving closer to becoming operational reality. If you enjoyed this deep and research-based aviation documentary, let me know your thoughts in the comments below. Do you think domestic aerospace independence will become the future of global aviation, or will international cooperation remain essential for aircraft development? Don't forget to like the video and subscribe for more high-value aviation content exploring the real strategies shaping the future of aerospace.